remember from geometry learning about sine, cosine, and tangent. Yes, good. That's what we're going to kind of work on today. So angles. Again, we are not measuring angles in degrees in AP Precalculus. There's no 30-degree angle. All right, so it's going to be a little different. So an angle that's in standard position angle, so like side of the angle. When that side is on the positive x, is right here. Okay, and then the is somewhere else. And that other side, that other ray, is called the terminal ray. That just means it's in standard position. Honestly, the only reason you need to know that is probably because on the question it'll say the angle is in standard position. Okay. So we're going to review sine ratio fraction. Does anybody remember what the fraction is that goes with sine? It's a fraction. What's on the fraction? You may remember?
Opposite over.
Yes. It is opposite you may probably learned SOHCAHTOA or one of the acronyms. So SOHCAHTOA works if you know how to spell it. SOHCAHTOA. S-O-H. So S stands for sine, O is on top, H is on bottom. Okay, so cosine would be what? Hypotenuse. Yep. And tangent is?
Opposite over, yeah.
Adjacent?
Yeah.
And if you remember, you hopefully do, when you have an angle, okay, you also always have a right angle. So the hypotenuse is always the one across from the right angle, always. The opposite side is the one across from your angle that you're kind of focusing in on. And then the other side is your adjacent. Triangle of theta b. In this example with these numbers, what's sine? What's the fraction?
0 over h.
That's O for opposite. But what numbers? 3 over 5. Mm-hmm. What is cosine? Three over 4. Opposite is 3, adjacent is 4. Honestly, we're not going to be doing a lot of right triangle trig. I'm going to introduce it. We're going to learn about something called the unit circle, which like a little fill it out. Okay. All right, so we're going to be talking about the unit circle. And I have the 7.07 is this length right here, and 5.55 is this point. And I'm going to fill out sine of theta, cosine of theta, okay. Here is where theta is. I know this is 7.07. What would the legs, each side of my triangle, what would their length be? Any ideas? What does it mean that this point is 5, 5? What is a coordinate? What does that tell us? How do you plot a point?
Is it 5?
Yep. Actually, both of these legs would be 5 because you go over 5, up 5. So this length would be 5, that's 5. So when you have a coordinate point, if you're starting at the origin, the x value is how far left or how far right you go. The y value is how far up you go. So you go over and up. Okay. So based on this triangle, we do SOHCAHTOA. What would sine of theta be? Here's my angle. Sine is O over H. Yep, 5 over 7.07. What would cosine be? Yep. Adjacent. So this over here would be my opposite. Hypotenuse, adjacent. What would tangent be? 5 over 5, which happens to be 1. I want you to try example 2. Notice this is like 0.9, comma 4. So try that one. So if I create a right triangle, it's going to look like this. This is 1. What's the length of this base right here? 0.9. Yep. And then the height? 0.4. Okay. And this is where my theta is, my angle. And so the 1 would be my H because it's across from the 90. The 0.4 would be my opposite because it's across from theta. And that leaves the other one to be adjacent. And so sine would be 0. Cosine is A over H, so 0.9 over 1, which happens to be 0.9. And tangent of theta is O over A, 0.4 over 0.9. Any questions on those? All right, now last one, this one's a little tricky because the terminal ray is over here on the left side, so we have some negative numbers. And normally when we have a triangle, we would not have a negative side length. But we're going to see when we get into trig, we are going to have some negative numbers. So we're going to have some negatives. And this is going to be my theta. So that would be 1. What would the base of my triangle be? Yes, negative 0.35. And then my height? Yep, good. Sine. So this would be my hypotenuse, the 1. Across from theta is my O, which leaves the other one to be my A. So sine is O over H, which just happens to be 0.93. Cosine is A over H, negative 0.35 over 1, which is negative 0.35. And tangent of theta is O over A, which is that. I really don't think SOHCAHTOA is really in the pre-cal curriculum. I don't think it is. I could be wrong, but we're doing some more advanced trig. But this is just kind of getting you into it. Alright. Example 4. So this one, we're given a little bit of different information. I don't know exactly where P is, so we are just going to refer to that as X, comma, Y. So if it doesn't tell us, if it doesn't give us any values, you're probably just going to use X and Y. Yes.
But the X down there is 3 points.
That's this point right here. So to get from here to here is 3.
But it should be the same distance, shouldn't it?
Yes, from here to here. So, but this length, that does not make that 3, 0.
Okay.
This is the coordinate 3, 0 because it goes over 3, up 0. I don't know exactly what the coordinate of that is, but that is necessary for telling me this length right here. Okay? Because in a circle, we know the radius is the length from the center to any side. So if it's 3 units here, this also has to be 3 units. Which means from here to here is 3. And from here to here is 3. All of that is 3. But for what I needed to know that that was 3. And this is I go over some value of X and go up some value of Y. Right. And so if I'm going to use this, my sine, cosine, and tangent is going to have X's and Y's as part of it. So angle So what would I call the length of the base? Nope, that's the hypotenuse. If the base was 3, my triangle would come all the way over here. Nope. It's just X. That was a trick. Because I don't know what this point is, so I don't know the number. So what would the height be? Y. Yep. So now fill in your sine, cosine, tangent. For sine of theta, you should have y over 3. Cosine theta, x over 3. And tangent of theta, y over x. I want you to see what you can do on number 5. Now, I'm going to outline the triangle that you need to have. You can use that for theta. So, I want you to recreate that triangle with what lengths that you can figure out and fill in sine, cosine, tangent. Here's what you should have drawn. This is 3, this would be -4, and this would have been 5. Because this right here is the point 3, -4. Alright, and then sine, this would have made sine -4 over 5. Cosine would be 3 over 5. Example 6, label the coordinates of Q, R, and S. So really all you're doing, if we know that this point, we're just calling this X, Y. Q, R, and S, I'm not looking for those to have numbers. What would Q be? Yes. Yeah, that's what I'm looking for. -X, Y. Because you go negative and then up. What would R be? -X, -Y. And then S is positive. And we're going to stop there for today. I am going to give you, before I stop the video, some instructions, some more explanations on the homework. So let's look at number 1. It's real wordy. It says, the figure shows a circle centered at the origin with an angle measure of theta in standard position. The terminal ray of the angle has the coordinates. Oh no. I don't know what this was. I've messed up. I've copied and pasted. Oh no. The terminal ray of the angle, I can't read, intersects the circle at point P. The coordinates of P are x, y, and the coordinates of Q are x, -y. That's not on there, so you may just want to jot it down. But the angle that we're talking about, so this ray is always part of it. That's always part of a normal angle. It says the terminal ray of the angle intersects at point P. So I'm going to go to the other one that intersects at point P. This is where I need to draw my triangle. You might, sometimes it just gives you, it also notices this is XY. So I'm not going to finish solving that one out. I just wanted to help you get where you draw your triangle at on that one. And then it's asking about sine. You're getting sine of theta. Number 2, the figure shows a circle centered at the origin with an angle measure theta in standard position. Da, 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 da. So this is one side. Okay. The terminal ray of the angle intersects at point Q. the coordinates of P are 4, 3, and the radius is 5. And it's asking for the cosine. Now here's the problem. We can't draw a triangle right there and make it a right triangle. But what we can do is, let's see, we can, let me make sure it gives me the right answer. Yeah. So we can, it'll work if you use this triangle right here.
Pardon this interruption. At this time, I need Honors Club officers to report to Miss Stevens' room. Honors Club officers, report to Miss Stevens' room.
You'll get the same answer if you make the triangle right there. And then, so circle centered at the origin with an angle measure of theta in standard position and the line segment connecting the points P and R. The terminal ray of the angle intersects at point R. Okay. The coordinates of point P are 5, 12, and the radius is 13. Alright, let's see. So this one, it will work if you make your triangle right here. And so try those, and then, let's see, let me look at the back. So if you just look at these on the back, when it's talking about point Q, you're going to use the triangle that's up here with Q. When it's talking about point S, you're going to use the triangle down here. Point R, you're going to use, you really can use here or up here. I would make the triangle sit against the x-axis. So I would use that one, this one for R, this one for P, this one for S. Yes, sorry, my bad. I would use this one for Q, this one for R, this one for P, this one for S.